It's right there. Can you read this? Yes? Good.
Just trying to hopefully not fry. For sparks. The magic.
Good to go. Sounds good. Okay, so everybody should clone this repo up here. If you can't see it, I can make it bigger. And if you have connection issues, then we have a USB as well. But that has the data and the tutorial as well. It's for you. We should put the Mongo restore command on screen as well, unless it's in the README.
Oh, yeah, it's in the notebook.
Okay.
Or, yeah, we can put it.
Where is it in the notebook?
Oh, no, it's not in there. I'll type it. Yeah, it's so it's my EuroSciPy conflict 218. Okay. So my okay, so 2 in the beginning and in the end. Okay. Thank you.
Everybody cloned the repo? Got it. Okay. Do you have the USB?
Yeah.
Yeah.
Would anyone like to use the USB?
right, so while everything is downloading, I can start. So first things first, I want to introduce myself. My name is Anna Herlihy. I'm a software engineer on the Compass team based out of Stockholm. I was a Python programmer for a really long time, and now I kind of code a bit more JavaScript. But for the most part, I am here to tell you about how to do data science with MongoDB. So this is Nathan. I don't know if you want to introduce yourself.
Yeah, so my name's Nathan. I'm an engineer on the education team at MongoDB. So I get the privilege of building tutorials to teach other people how to program, as well as building a lot of internal tools for my team. That's me in a nutshell.
Cool. So how many people here have used MongoDB before? Hopefully heard of it if you went to the last tutorial. All right. So the basic idea of MongoDB is that a lot of the times you have data that lends itself more naturally to a document format. So maybe your data is columns and rows and perfectly fits into SQL, in which case that is the tool you should be using. But more common nowadays, data comes in more complicated formats. And so if you want to have your data management be very easy, I recommend using MongoDB. But the issue is if you're a data scientist and you want to do analytics on your data, you do want to put your data in those rows and columns, or you want to put it in a matrix, or you want to use your favorite analytical program. So in this case, we're going to use Pandas, Matplotlib, and Seaborn to do some visualizations, but you can also use whatever you like. But the idea is that you keep all of this data in MongoDB, but you only need to use some of it. And you don't exactly want to move all of the data from your data store over the wire and into your NumPy MD array if you don't actually need to use all of the data. So if your network is a bottleneck, or if you just don't want to deal with that much volume, you want to be able to do operations on the database side so that you don't have to waste time and energy and likely money. So what this is here is the idea that you do not want to take your entire shipping vessel into the harbor. You want to take only the things you're going to offload. So that is where the MongoDB aggregation framework comes in hand. So the first thing we're going to do is we're just going to put some data in MongoDB. We're going to put the same data in Pandas data frame, and we're going to look at the different things you can do and compare the syntax. So hopefully somebody has been able to clone the repo. If not, you can watch me, but this will be available for long after the tutorial. So if you don't have everything set up right now, you can still follow along on the screen, or you can ask for help and we can come try to set that up once things get going. So the first thing to set things up, I am going to install my various packages. In this case, I'm using Pandas, Seaborn, and Matplotlib. What this up here is doing is it's showing you how to set up your database. So I'm assuming it said pre-tutorial that you have to have MongoDB installed. So most people have that on their machines, correct? Good. If you don't, then this might not be the most tutorial. But the idea is you create a database running locally. So if you don't specify host and port, it will run on localhost on 27017, which is, there is a dump folder within the repo which has all the data you'll need for this course. And then another optional thing you can do is you can download Compass. So Compass is what I work on. So obviously I think it's the coolest part of the tutorial, but it is basically a graphical user interface for MongoDB. So for people who are not necessarily comfortable in the terminal but still want to manage their data, if you're a DBA instead of a programmer, or say you just want to gain some insight from your data and you don't want to have to sift through a bunch of terminal code, you can use this application. So let me show you what that looks like. So this is Compass. I can connect to my database with authentication. I can set a specific replica set, but all I really care about is that I have this database with this data that we've preloaded. So what the data actually is anonymized data from the online education courses that MongoDB provides. So this is real anonymized student data. It has information about the courses that students have taken, as well as the exams they've taken and the sort of the frequency for each user ID. I see a lot of people squinting, so I don't think it looks very clear. I don't know if there's anything we can do to make the resolution better. Or maybe we can close the curtains in the back, so maybe it's less bright. Thank you. Maybe it's my hair. Doesn't
Si riesce a togliere quel fruscio, se ci permette, non so poco.
Who wants static and loud voice, or me yelling and no static? Option number 2, raise your hand. All right, okay. If you don't hear me, just let me know and I'll scream it again. So, this is MongoDB Compass. This is an overview of all of my documents. So, as you should have learned in the previous tutorial, or if you've used MongoDB before, you know that a document looks sign. Thank you. Have a dollar sign before the operation name. So in this case, I have add fields, which, as you would expect, adds a field. And what I'm adding is a field called isEven, and the result of that operation is going to be this field, which is going to be a Boolean value. And it's just doing a mod to see if the result is even. Once I've added that isEven field, I then do a $match stage. So $match is basically the same thing as doing a filter. So you can go through and say, give me all of the documents for which isEven is true. And the result of that is going to be the list of even numbers. A different way I can do that within the MongoDB aggregation pipeline is this $expr. So this is just a syntactic difference, and it's slightly shorter, but it's basically doing the exact same thing, except for it doesn't bother adding that intermediate field isEven. It just immediately matches the documents which this sub-expression will return true for. So, sorry, I can't type and hold this at the same time. As you can see, there are 50 even numbers, and there are 50 even numbers. So this is just to show you that the two things are equivalent. The only difference is that in the second option, or sorry, in the first option, it has this isEven field, which maybe you want to use it again at a later point in time, and you do want to add that field. But also, if you don't care about that field, there's no point in storing it, so you can use the second way to do it, which does not have that. This is just the pandas way to clean my data up a little bit because I don't need the ID field and I don't need isEven. So once again, I have my even numbers. So let's talk about what we just did. So what we didn't do is a search. We didn't just ask the database what is the number. Can you hear me? Is this working? What we didn't do is just ask the database how many of these fields are even, because the information and the calculation is happening on the database side before it's passed over the wire to the pandas data frame. So the pipeline itself, it's important to emphasize that it's an actual data pipeline. So each one of these stages happen, and the documents that get passed through that stage then get passed to the next stage. So the three most common of these stages is match, project, and group. So match, as I mentioned before, is just a filter. So what that's doing in this diagram is it's going through and it's removing the squares that are green. The next stage in this example is a project. So $project is the operation you would do if you actually want to modify your data. You can choose to exclude fields, you can include specific fields only, and you can also compute results for new fields. The last stage in this pipeline is $group. So what group does is it actually gives you insights about your data in relation to the entire collection. So as you can see with the first two operations, it passes through each document one at a time. While in the last stage, what group does is it takes the entire collection and then it spits out a result with information about how, in this example, how often each one of the colors occur. So it's similar to locate, similar to find, and select for those people who use SQL. So now I'm going to talk about expressions. So we saw expressions earlier when we were doing the $mod in order to figure out whether or not the field was even. But what we're doing here is we are comparing what an add operation would look like between the two, between something you would do in Python and something you could do in the aggregation framework. So expressions are just functions. We can use them in the exact same way that we would program any other language. So they're composable. And you can sort of think about them like if the match, project, and group are the sort of tables in your assembly line, the expressions are the tools you can use in each one of these stages. So this is what it would look like to run an add operation. This is what floor would look like. And then if you wanted to come up with a new operation that doesn't exist, you can compose the two operations and create a round function. And this is just some semantic information that you can read about after. So the last thing to know about expressions is that if you want to reference a specific field within a document, you can use something called a field path expression. So if I have a document whose name is has a field named value, I can access that within my operation, within my expression, with a dollar and then the name of the field. So we had that earlier when we were testing if the value field was even. The way we access that is by doing the dollar sign next to the value. So there are a bunch of different categories. A lot of things are defined for you, like floor, add, subtract, etc. But you can also compose them to create more complex operations if you'd like. There are also array and object operators. So say you have an array that you want to turn into an object, or you have an object you want to turn into an array, or you want to index into an array, or you want to do some kind of operation on every element of the array. All of those things are defined. You also don't need to memorize every single one of the operators because we have a quick reference page on the MongoDB docs, and there are so many operators, it's probably not worth your time to memorize them all. So the add fields operator is the same thing that I described earlier. It's basically very similar to project, but there's a very key difference between add fields and project, which is project, you can choose to exclude fields, and you can choose to add new fields, and you can choose to keep the value of a field the same while dropping everything else. So it's a lot more powerful than add fields because add fields just adds a single new field or redefines a field if it already exists. So this is an exercise. How many people are able to run anything locally on their machine? Cool.
Can you put back how to connect to the Mongo?
Yes.
Because that's not on. Yeah.
Cool. I don't know if that's readable.
What's the URL to the notebook? I missed that. Just about.
Ah, okay.
Just about. They want to see that.
This one? Oops. This.
Thank you.
Yeah. So this operation I don't think this is not in the repo yet because I just added it, but this is if you want to connect to your database, you need to start your database and give it a path to an empty folder, which is where the data is going to be stored. And then running a Mongo restore from the dump field will populate the database with the data we're going to use in this example.
Does anyone need help getting it set up locally?
And for the people who already have it cloned, if you have Jupyter installed, you can run Jupyter Notebook from that repo, and it will show you exactly what I have running on my machine, where you can fill in your own solutions to the problems and run them.
Where is this Mongo restore?
No, 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 no. It's part of the MongoDB.
No, it's for the Mongo. Yeah,
It should. So you may need to install Mongo restore.
did you find it?
So you install MongoDB. Um,
So yeah, can we restore it some other way?
yeah.
Has anybody got any questions while we are setting things up?
But now I have like maybe about
So, when you process the data directly with MongoDB, can you do kind of like NumPy operations as well? Like something more complicated than just adding multipliers to it?
There's some. There is like MapReduce, and there is some statistical stuff like standard deviation, that kind of thing. But realistically, if you want to do analysis on really big data and you want it to be fast, it's a lot more effective and a lot faster to do it on the client side in an analytics tool like NumPy or something. So only in the simplest cases, I think, can you do it on the server side. Okay, does anybody need the instructions on screen for longer? Speak now. I can, yeah. All right, so I'm going to go through the first exercise, but to summarize, everything I have said so far can be summed up by if you have a lot of data, you can put it in a database that is very easy to use called MongoDB. When you want to do analytics, you need to move your data from your data store into whatever tool you prefer to use. And so that problem of moving your data from A to B exists no matter what database you're using or what data store you're using. So what I'm going to talk about specifically is if you're using MongoDB, how to get the most out of that transaction. So how to do some expensive operations that will thin your data over on the database side. There are operation stages like match, project, add fields, which will be basically stops along the assembly line as you pass data down the data pipeline. And then there are expressions, which are the individual operations you can do on the data, like add, etc. So the first exercise is we are going to try to use match and add fields to get the number of submissions to MongoDB University that happened on a Tuesday. So something that's important to know is that if you take a MongoDB course online, the due date is always on a Tuesday. So this information is in the student course collection. So I can go into Compass and I can see basically what this data looks like. So there's a schema tab, which will give you sort of an analysis of your schema. So you can know how many fields you have, what types they are, etc. So the exam results collection is not actually the collection that I want. I want to use student course. So this might take a second because it's a very large database. And this is doing a sample of all the documents and building charts based on the types. So we have information about the chapters, which is going to be a document. And we have some arrays with our lesson maps. And then the offering, which is the name of the course and the year and month in which it was offered. And then the average score. And then this field called tab map. So tab map is a document that contains a bunch of information about the specific users who took the tests and the courses, as well as the number of attempts for each homework and when they submitted it. So this is where we're going to want to look for our information on when people actually submit results. So I can go over to my aggregation stages, which right now is empty. And the way that this works is that for each one of my stages, I can choose my operator, and then I can fill out the fields here, and then it will show me a sample of the documents after that stage. And I can do that for each stage in the data pipeline. So this isn't required to do it at all, but it is really nice to see each individual stage, the changes reflected in the documents. So the first thing I'm going to do is I'm going to add a field to my document called day of week, which tells me the day of the week. So To do that, I need to look into the data itself and see what it looks like. So I have attempts, and then I have my date here. And then for those of you who can't wait, you can load the solution here. So one of the operations that is supplied is something called $day of week, which takes in a date object, and it will tell you the day of the week as a number between 1 and 7. So what I'm going to do here and then for that, I'm going to use the field that has the date that I'm looking for, which according to the solution is a field called updated at. And then for the next stage, I want to do a match. So since we know that Sunday is 1 and Saturday is 7, what day is Tuesday? 3. Sure. So now we're matching that day of week is 3. And then the last thing we're doing is we're doing a count, because we are curious to know how common it is to have a submission on a particular day. So we need to transform the data from just the set of documents to the actual number of times the day of week shows up. So if I press enter, I have this value, which is the number of submissions on Tuesday. Because the count operator will do a count of the number of documents and then store it in the field that you give it as an argument, which is called submissions. So I can run my solution, and it is not the same, and that is because Tuesday is actually 2, not 3. Sorry. Because I guess it's 0 indexed.
No, it's Monday. 2 is Monday.
Right. Because it would also defeat the purpose of this exercise, which is to show you that people procrastinate and hand in their homework on Tuesdays much more than if they were to do it on a Monday or a more reasonable time to do it. So, yeah. All right. Nathan, do you want to take over? Are there any questions about that so far?
Can I just ask a general question? Obviously, doing this processing on the MongoDB side requires learning how to do these things. So, in terms of speed and memory, how does it compare to doing it once you've actually dumped the whole thing into, let's say, a data frame?
So I did not include an example in this tutorial showing that. However, in a course that I put together for Coursera for MongoDB and data science, we run a time it, and we also look at resource usage to do a correlation between two variables on a data set that is, I think, about 500 megabytes. And in MongoDB, it finishes about 500 times faster and uses way less memory. And again, it goes back to the cargo ship, right? You don't need to bring everything in. You're just really saying, this is what I want, send this back down the wire to me. MongoDB benefits from the fact that there's no interpreter running. It's just native C++ running at the speed of whatever you've provisioned your servers to. So, any other questions up until this point? All right, so don't know if we mentioned, this was actually done as part of a real data analysis job that I did for MongoDB University. So we didn't have you guys clone the full data set, but it is there. We'll make it available after this tutorial. And we had to put this together for metrics because you can't improve what you're not measuring. So we found all sorts of interesting information out. And you guys are getting a sample out of it here. All right, so group. Who is familiar with grouping operations in, say, SQL? Show of hands. Pandas group by, anyone use that? Okay, so group is very similar and then a little bit different in a way. So group has this following form, $group, just like all the other aggregation stages, and then underscore ID followed by an expression, any arbitrary expression we want. And then we have field N. All right, this is a name that we make, again, completely arbitrary, and accumulator N, accumulator, or expression N. So these are where we use group accumulators within MongoDB, is after this fact. Like I said, an underscore ID can be any expression that documents, you want documents to match together with, to group by. Field N in pandas, this might be like .ag at the end of it. Here we go. So we'll play around and see what we can do with group. So first, let's go ahead and put 100 documents into MongoDB. And we can see here that this is just a sample. The first document gets a random underscore ID. MongoDB does this for us. And a value of 0. So they go from 0 to 99. All right. So grouping by odd or even. And you might see something new here that you haven't seen previously in the notebooks, which is the $cond operator. All right. So the $cond expression is an expression that is basically if, then, else within MongoDB's aggregation framework. So we can read the first part as if, this, then even, or odd, or else odd. We also have a count with $sum and 1. So $sum is a accumulator expression, and summing 1 to it essentially makes it count every single document that adds in. If we imagine that that has a placeholder value of 0, as the first document matches, 1 gets summed to 0, and we get 1. Next document comes in, 1 gets summed to that number, and we increase by 1 every time. All right, and we see that math does still work. We have 50 odds and 50 evens between 0 and 99. Things are good. So like I said, we can read this as if, then, else. This was a shorthand up here. If you're not comfortable with this, if you want to type out if, then, else, you actually can. Cond has another form that supports that. All right, so I talked about that the accumulator expression block. So we called it count, but it could really have been any name. And then we used the $sum. I covered the way that we count as we match documents, so I don't need to cover that. And here's an example, almost identical example. I'll run it. We can see the difference. So notice that there's no even odd, right? Because I didn't use the $cond to give me back the strings, even or odd, I actually got back the raw result of the evaluation of is it equal to, or is it evenly divisible by 2? So 50 false, 50 true. All right. So let's have a little fun. How many of you have ever heard of the incredibly hard puzzle of FizzBuzz in like a programming interview challenge thing? Anybody? Anybody done it? Few over there? All right. So it's notoriously difficult. It weeds out a lot of people in programming interviews. So the idea is that if you're not familiar with it, if the number is evenly divisible by 3, you output fizz. If it's divisible by 5, you output buzz. And if it's divisible by 15, you output fizzbuzz. And if it doesn't meet any of the criteria, then you don't do anything. You just output the number itself. So we're going to use another accumulator expression called push. And what this does is it takes the value that matched and shoves it into an array named whatever we want it to be. All right. There is an alternative to push called add to set. You may be familiar with set operations. So if you need uniqueness, you would use add to set. Beware that it is a slower operation because every time it goes to push it in, it needs to check to see if that value does exist so that there's no collision. And in order to do FizzBuzz, we're going to use a new expression called switch, which is in aggregation. Most of you are probably familiar with it. That way, we don't have to nest dollar cons like this and end up pushing our code off the side of the screen. So we can see here what it looks like, and it's still kind of pushed off to the side. So switch has a couple branches. We see if it's equal to mod value of 15, then we put FizzBuzz, 5 is buzz, and 3 is fizz. And otherwise, the default, we give it plain. Now, the reason that we do this is because as you group and you use your expressions within a group, group stops at the first match. And in a switch, it's going to stop at the first one, right? So there's no need to put a break or anything like that. It's just going to keep going down, or it's going to stop as soon as it matches. So we need to start at 15, then 5, and then 3. So running this, we can see that we have matching numbers for buzz are all the multiples of 5, minus a few missing, like 30, 15. Fizz, all the multiples of 3. And then plain, and lastly, FizzBuzz, 0, 15, 30, 40, so on. All right. We can also group all input documents together. So it may not be necessarily handy to group documents based on whether they're divisible by 3 or 5. Or any other criteria. You may just want to group them all together to do some statistical analysis, like get your standard deviation or your mean, get your min, max, things like that. So the canonical way to do this within MongoDB is just to specify 0 as the underscore ID, as the expression. Essentially, no document can match 0, so every document matches, and they all get grouped together. So if we run this, we can see the numerical accumulator expressions work within group. So we see 0 to 99, the max value is 99, min is 0. Get the average, the sum, and the standard deviation. All right. So here's an exercise for you guys. Group problem submissions together based on the day of the week they were submitted and output a count. Anyone having issues with this? Any questions? Yeah. You finished? All right. All right, is anyone finished with the exercise? Got one, few hands. Okay. All right. Is this what you guys that are finished got? Something pretty similar? Okay. Yeah. So again, underscore ID can be any expression. So here we use the day of week expression and then the field path for updated at. So this gets us the day of the week. So all documents that match 1 for that will get grouped together and we'll get a count up through 7. Nope, doesn't quite make it. All right. So let's sort them in descending order so that they're greatest to least, so we can see which day of the week students are most active on. Right? So we have this one, and then we can add a sorting stage to it. And sort works similar to sort in pretty much everything else. So we specify what we want to sort on and then the direction we would like it sorted in. So -1 is in decreasing and 1 is in ascending order. So running this, we can see that day 2 has the most, which is a Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Or, sorry, Sunday and then Saturday. People actually drop off significantly here. Now, we actually don't need to do this. This is such a common operation that we've added a stage called sort by count. What sort by count does is it takes an expression that you want to match documents together on, and it says, okay, I'm going to go ahead and throw a count stage in there and then sort on that for you. Because people, everyone was asking for it. So if we run this, we can see just with the sort by count stage that we got the same exact result in a more succinct manner. All right, so we're going to skip past the lookup for now and do some actual analysis. All right, before we jump into this, one stage that we need to cover that's, well, we need to cover 2 stages that are pretty important. The first one is facet. So facet is probably the most powerful aggregation stage that there is, and it's really the most misunderstood. A lot of people don't understand what it does. What facet does is processes pipelines in parallel, and each pipeline is in its own environment, and it does not affect the outcome of the other pipeline while it's going through facet. All right. So we can do multiple things that may be destructive to one data transformation pipeline. Within a facet, we can do something else along with it that won't be destructive, and then combine the 2 afterwards. Oftentimes, you'll find a facet used with one of our set expressions in like an add field stage after the facet to see if like you have any overlap between 2 distinct groups that you calculated. All right. The other one that I'll show you is bucket. All right. So what bucket does is it's kind of like group in a way, but it's instead of not really having any control over the amount of buckets you have, we specify boundaries for the bucket stage. And then things will get evaluated by this group by expression here, which is we get the hour for updated at. So here we can see I'm matching based on the day of the week that it was updated at. And then I'm getting the hour, all right? And I'm going to bucket them, basically I'm going to bucket all of the matches into an by hour by day, all right? And it takes the output, or the output is where you would put your accumulator expressions like you would in a group stage. So here we're just going to count the number of matches. Yes?
Sorry, is bucketing the same as like binning your data and choosing the bin edges?
Yes. Yes. That's a good point, good question. So some people wonder why is the range 25 here instead of 24? A bucket isn't fully defined until you define both edges of the boundary. So if we only went to 24, we would get a lot of non-matches. We would miss that off hour. So here I've just defined a function to help with the aggregation, so I don't have to type 7 aggregations over and over and over. And then down here, I just use a facet. So I'm getting Sunday, Monday, Tuesday, all the way through Saturday. If I tried to do this in a single aggregation stage, it's possible. It'd probably be about 500 lines of aggregation and jump off the edge of the screen with a lot of really gnarly conditional statements. So